Good morning, one and all. My name is Abhijit Kumar. My roll number is 249518662. I am studying in CSE, AI and ML, that is Computer Science and Engineering, with a specialization of Artificial Intelligence and Machine Learning, 4th semester, Institute of Aeronautical Engineering. In this video of complex engineering problem of the subject of applied artificial intelligence, the topic I am going to talk about is ontology based knowledge graphs for automated legal reasoning complex engineering project. Hence, let's dive into the video. Now let's go through the contents first of all. In the first place, I'm going to explain the context, motivation and role of AI in legal systems. That is, I'm going to introduce the topic, and next I'm going to explain the problem statement, the gaps in current legal interpretation tools, and next I'm going to explain about the proposed solution, that is AI based reasoning using ontologies and knowledge graphs. Next I'm going to explain about system design and implementation, that is architecture, workflow and code details. And after that I'm going to execute the code and I'm going to show the output, and after that finally I'm going to explain the outcomes and future directions. That is, I'm going to conclude the topic. Now let's go through the introduction. Today, legal systems are inherently complex, governed by layered rules, statuses, and interpretations. Traditional approaches rely on manual legal expertise, a process that is time-consuming, expensive, and prone to error. AI offers a structured alternative. One is ontologies. They formally represent legal concepts, crimes, laws, and actions in a structured, machine-readable format. Knowledge graphs. They map the relationships between legal entities, enabling contextual understanding beyond simple keyword search and automated inference. They apply rule-based reasoning over knowledge-based to derive legal conclusions from user-submitted complaints. Hence, this is the introduction. Now let's go through the problem statement. The gap in the legal access. Most citizens cannot independently navigate the legal system. Existing tools are either fully manual or rely on rigid hand-coded rule sets with no capacity for intelligent inference. There is no automated legal interpretation for everyday complaints. There is a lot of difficulty in identifying applicable laws, that, for example, IPC sections, and there is a high barrier to entry for non-experts seeking legal guidance. This is the problem statement, and the proposed solution for this problem statement is that AI-based reasoning engine, an ontology-driven system that analyzes complaint text and matches it to a structured legal knowledge base and infers the crime type, relevant IPC section, and recommended action. Ontology encodes crimes, keywords, laws, and actions. Knowledge graph principles structure entity relationships. Rule-based inference engine drives automated reasoning. Hence, this is the proposed solution. And the system design. In the front end, I have used the user input complaints via web form, and backend Python Flask handles the request and response, and the ontology knowledge base is the crime keyword law action dictionary. Step by step workflow. Step 1, user submits the complaint in the form of free text input through the web interface. Step 2, Flask backend receives the request. Post root triggers the reasoning function. Step 3, ontology matching. Keyword scan Keywords scanned against the crime dictionary. Step 4, result returned to the user interface. Crime type, IPC section, and action displayed. Here each layer is independently defined, making the system modular and straightforward to extend with new crime categories or legal jurisdictions. Hence, this is the system design and implementation. Now let's go through the execution. At the back end, Python is used. Here an ontology. Here it is a dictionary with uh, with a crime name as a key, and another dictionary with the keywords, the law, and the action to be taken as another dictionary. That is the value of the crime, that is the ontology defined, and a legal reasoning function is defined with a attribute, with an attribute text. By entering the text, the crime is identified through the ontology, and the crime, the law applicable, and the action to be taken are returned. This entire logic is done in Python, and at the front end the main logic is that the text area, the form tag, and the crime, the law, the immediate action to be taken, all of them are included in HTML plus CSS. Here the key features are: this system is ontology driven, that is the crime categories, keywords, IPC sections, and actions stored in a single extensible dictionary. Fast keyword inference, the linear scan over ontology entries returns first match with law and recommended action. The graceful feedback, unrecognized complaints and return an unknown result, directing users to nearest police station. And the minimal stack, Flask plus Jinja 2 templating, no external machine learning libraries used for the core reasoning loop. The output is that the UI, the user interface, renders crime type, IPC section, and suggested action for every submitted complaint. Hence, this is the execution, and by executing the entire code, you can see the first user interface page. In that page, let's say uh, I entered any crime, the analyze complaint button clicked, it returns the crime type, the IPC section, and suggested action for every submitted complaint. Let's say I have entered he attacked a kid. Let's say I entered he attacked a kid. By entering that, if I click on the analyze complaint button, it returns the crime type assault, the law applicable is IPC section 351, and the immediate action is to seek medical and legal help. Hence this is the entire execution. Hence this is the successful execution. And finally, I would like to conclude the topic by saying that this project demonstrates that ontology-based knowledge graphs can effectively automate foundational legal reasoning, reducing dependence on manual expertise and making legal guidance more accessible to citizens. The impact is that it bridges the gap between citizens and legal system with fast structured guidance. The scalability is the ontology dictionary is easily extended with new crime categories and jurisdictions, that is the scalability of it. And the NLP for semantic understanding, ML models for classification and integration with real-time legal databases can be considered as future work. And overall, this system represents a scalable and intelligent foundation for next generation legal AI, where a structured knowledge meets automated inference to serve justice more efficiently. Hence, this is the conclusion of this topic. And to the respected professors, I would like to sincerely thank the respected professors for giving me this wonderful opportunity to speak upon this wonderful topic. Thank you.